Hi everyone. So in today's video, we're going to be looking at some examples. So basically just going to be spending the whole video doing examples of functions that are a little bit more complex than the ones that we did earlier in the week, where we're going to have to use both the chain rule and either the product or quotient rule. Or in one case, we're going to have to actually use the chain rule twice. So the point of today's video is really going to be to give you some practice with being able to look at a function and kind of untangle, what kind of function is it? What do you need to do in order to take the derivative? And kind of like, most importantly, in what order do you need to apply some different rules? So I want to start with an example. And I'm just going to write down two functions, and I want you to kind of think about what is different between these two functions. Like if you had to describe or maybe even in the lens of derivatives, if you had to think about what kind of rules are you going to use on these, what might be different about your use in these two examples? So the first function is x squared times sine of e to the x. And the second example is sine of e to the x times x squared. Or I guess I like to write it this way, x squared e to the x. So these look really similar, right? They have the same kind of pieces, just arranged in a different way. So what I like to think about with functions and trying to figure out what derivative rules, I like to use this kind of idea of like zooming out and thinking about big picture, what type of thing is going on in the function. So kind of on the outermost level, what is happening in this function. So if we look at the first function, f of x, this function is a product of two different functions, right? So we have x squared and we have sine of e to the x. So this is a function that is a product of x squared and sine of e to the x. And maybe I'll move that other one over a little bit. So there's something else going on though, which is sine of e to the x. Well, that is a composite function, right? And so what is this telling us? This is telling us that we're going to have to use both the product rule and the chain rule. So which one are we going to use first? Well, on the outermost level of this function, it's a product, right? Like what did we write down first? We wrote down product, right? It's a product of x squared and sine of e to the x. And then sine of e to the x, that happens to be a composite function. But first and foremost, this function is a product. So we're going to use the product rule first. On the other hand, this function here, and maybe a good way to decide, what are you looking at in terms of the function is literally read it out loud. So going back to this example for a second, if you read this function out loud, you would say f of x is equal to x squared times sine of e to the x. So you have two things that are clearly being multiplied together, and you didn't say sine of something times something else. You said x squared times sine of e to the x. So the sine of part is what tells you, and the fact that the thing you're taking sine of is not just x, that tells you that it's a composite function in there. But because the first thing you're doing is multiplying, that's what tells you kind of first and foremost, this is a product. On the other hand, this one is sine of x squared times e to the x. So the first thing that this function is it's a composite of specifically sine of u and our inner function in this case is x squared e to the x. So x squared e to the x, well, that part is a product. And so eventually we're going to have to use the product rule, but it's not what we're kind of starting with. And I think the deciding what to start with is the very most important step, because if you know what to start with, it will just kind of happen naturally that you'll use the other rule when it comes time to. Okay, so let's actually jump into doing this example. And I know I've said this a few times, but I think this is now like really, really where that notation of putting parentheses around and the prime is going to be really useful. So how do you take the derivative of a product? Well, we use the product rule. So I'm going to write down the product rule without taking any derivatives. I'm just going to kind of write it down in its like base form. So the product rule says we're going to take the derivative of the first thing. So we're going to take the derivative of x squared, and then we're going to multiply that with sine of e to the x. And then we're going to take the derivative of sine of e to the x and multiply that with x squared. So just by kind of writing down the product rule and using this placeholder notation, well, on the next step, when we get to this part, we're going to have to use the chain rule, right? Because that's how you take the derivative of sine of e to the x. But because we kind of organized ourselves by setting it up this way, we'll know when it's time to use the chain rule, because it's when we get to that part. We don't need to use the chain rule in any of these other parts, because this is the only part where we're actually taking the derivative of a composite function. The rest of this is, you're not taking the derivative. Like here, you're not taking the derivative, right? It's just sine of e to the x. And then here, you can just use the power rule. So we're really just using the chain rule like kind of when it comes up is what I would say. So what do we get here? Well, the derivative of x squared is 2x. So we have 2x times sine of e to the x. And then for this other part, so sine of e to the x, so this is where I think it's, if you're always writing down your inside and your outside function every time you're doing the chain rule, I think when you get to these examples where you're using multiple rules, that's going to kind of slow you down and maybe confuse you more than it helps you. So the way that I would find the derivative of sine of e to the x is, again, first kind of start just doing like the outside part. So for kind of forget about what's on the inside and just take the derivative of the outside while leaving the inside alone. So what's the derivative of sine of something? It's cosine. So we're going to do cosine of that same input. And maybe let me color code this, because I think just so you don't get lost in all this stuff. So this part is what I'm writing the derivative of now. So the derivative of this is going to be, like we just said, cosine of e to the x. So that's the outside part of the derivative. But then we have to multiply by the inside part, so the derivative of the inside part. So the inside part is e to the x, and the derivative of e to the x is e to the x. And then we multiply that with x squared. And so altogether we get 2x sine of e to the x plus x squared e to the x cosine of e to the x. Okay, so let's see how this one goes a little differently. So this one, again, on the outermost level, it's sine of something, and it's sine of something that's not just x. And so that tells us that the first rule we need to apply is the chain rule. So we're going to start by going about the chain rule. And again, we'll see that we'll use that kind of placeholder notation as needed. So how does the chain rule work? Well, we want to first take the derivative of the outside part of the function, right? So what's the derivative of sine of something? It's cosine of that same thing. So we're going to leave the original input inside. But then we want to multiply by the derivative of that inside part. So I'm just going to write that down as x squared times e to the x prime. Right? So this is just, again, the chain rule. The chain rule is we're doing the outside derivative first. So we're first dealing with this sine, and then we're supposed to multiply by the derivative of the inside. But because the derivative of the inside is going to itself require to use the product rule, I'm kind of breaking, in order to not get confused about what are you doing when, I'm using this placeholder and just saying the derivative of x squared times e to the x, so that on the next step, we can actually find that derivative without getting lost in what are we doing when. So what is the derivative of x squared times e to the x? Well, that's going to be the product rule. And because this is a simpler product rule, I'm just going to kind of go straight for it. So we first take the derivative of x squared, so that's 2x. Then we multiply that with e to the x, and then to that we add the derivative of e to the x, which is e to the x, and we multiply that with x squared. Let's put that in parentheses, and then we're multiplying that with cosine of x squared e to the x. And I mean, that's basically it. I think I would personally probably put the this part in orange at the beginning, because otherwise it just looks a little like you're multiplying this and you're not, right? You're taking cosine of one of them and the other one's being multiplied. So maybe let's rewrite that so it's at the beginning. And if you wanted to, you could distribute it as well, but it doesn't really matter. So 2x e to the x plus x squared e to the x times cosine of x squared e to the x. All right, so let's do a couple more examples. So we're gonna do basically another pair of examples that are in some ways very similar to the ones that we just did. And then we'll do one that's kind of a standalone. Okay, so next example we're gonna look at is the first one is going to be f of x is equal to e to the x squared over sine of x. And the second example is going to be g of x is equal to e to the sine of x over x squared. So again, these have kind of the same pieces. They look very similar, but we'll see that the approach, like with the last one, is going to be kind of backwards for these two in terms of what are we doing first. So in both of these, we see some composite function happening, and we also see a quotient happening. So in both of them, we're going to be using both the chain rule and the quotient rule. It's just a question of what are you doing first. So for this first one, on the very most kind of outer level of this function, it's e to a power. And that power happens to be a quotient, but the function itself is not a quotient, right? Like, and maybe another way of thinking about that is you could not find two functions, let's call them, because this is already called f, let's say g of x and h of x. You would not be able to find two functions g of x and h of x that you could divide to give you this function as a whole, right? There's just no way. And similarly, going back to these two examples, this one, we saw that you could write it as a product. This second one, you can't write sine of x squared times e to the x as the product of two different functions, right? It's not a product of two different functions, it's sine of a product of functions. So here, there's a quotient happening within the function, but the function is not itself a quotient. And so this tells us that, let me just try to be consistent with my formatting here. So I put a bullet point. So this is a composite, or a composition. How did I say it over here? I said composite. Should probably have said composition, but that's okay. It's a composite function, and specifically, it's a composite function where the outer function is e to the u, and the inner function is x squared over sine of x. And it just so happens that x squared over sine of x, that is a quotient. And so that tells us that along the way, we're going to have to use the quotient rule, but it's not what we're going to do first. So we're going to start by using the chain rule. And maybe let me add that to these, because I think maybe that's something I should have said that I didn't. So this, because we said product rule and then composite, that really means that you're kind of starting by using the product rule, then doing the chain rule. Whereas this one, you have, and maybe let's say chain. This one, you're starting with the chain rule, and then later you're using the product rule. And so similarly here, you're starting by using the chain rule, and then along the way, you're going to use the quotient rule. Okay, so what will this chain rule look like? Well, again, we want to look at the outside function. So remember that when you have e to a power, the derivative of e to the x or e to the u is just e to the x or e to the u, right? It's just itself. And so whenever you're doing the chain rule and you have e to some complicated power, the first part of the derivative is actually just going to be the function itself. It's just going to be e to the x squared divided by sine of x, because that's the outer part of the derivative. Then we want to multiply that with the derivative of the inside function. So with the case of e to a power, the inside function is the exponent, right? So we want to multiply this with the derivative of the exponent. So I'll just write it like this. We're going to do x squared over sine of x prime. So what does that give us? So x squared over sine of x prime, that's where we now are going to use the quotient rule. So the quotient rule tells us that we take the derivative of the numerator, so that's 2x, and we multiply it with the denominator. And then we subtract the derivative of the denominator, so that's cosine of x, times the numerator. And then we divide that by the denominator squared. And so we're taking this whole thing and we're multiplying it with e to the x squared over sine of x. And so from here, I think for the sake of all of our sanity, let's not worry too much about simplifying this. So the way that I would probably just write this would be, maybe let's leave the e to the x squared sine of x kind of undistributed, but move it into the fraction. So this is an example of a fraction where you definitely could do some simplification. If you were to split this into two fractions, like especially looking at this part, if you split that into two, you could simplify the sign and you could kind of rewrite cosine over sine squared a different way. But it's kind of up for debate in situations like that, what is more simple. So let's just leave it like this because it's already kind of a complicated function. Okay, so let's look at the other one. So this one is first and foremost a quotient, right? Before it's a, before using the chain rule, we're gonna have to use a quotient rule. So this one is a quotient where you're taking e to the sine of x and dividing it by x squared. So this is a quotient of e to the sine of x and x squared. And e to the sine of x, well, that just happens to be a composite function. And so that tells us that we're going to start off by using the quotient rule, but that along the way, we're going to have to use the chain rule. So let's start by writing out the general format of the quotient rule, and then we'll see where the chain rule comes up along the way. So the quotient rule tells us that we take the derivative of the top. Sorry for that mysterious pop-up that I still don't know how to get rid of. So we're going to take the derivative of the top. Again, I'm using this kind of placeholder notation because then we'll know where we have to use the chain rule when we kind of come back to finish it up. So derivative of the top times the bottom. minus derivative of the bottom. That one's easy enough to compute, but I'm just going to leave it written like that for consistency, times e to the sine of x. So that's the top function. And then we're dividing it by x squared squared. Sorry, I'm getting very crooked on this. Okay, so now we can go through and focus on where do we actually have to use the chain rule. So the only place that we have to use the chain rule is this derivative, right? Because nothing else here, the only other derivative we have to calculate is this one. And that one doesn't require the chain rule. And then you might say, well, but don't we have another e to the sine of x over here? But we don't have to take the derivative of that one, right? That was just like, if we follow the rules of the quotient rule, you're only taking the derivative of the numerator one time. And that's the only place that we actually have to use the chain rule. So what does this look like? Well, the derivative of e to the sine of x, that's going to be e to the sine of x, right? Because the outer derivative is you just kind of leave e to whatever alone. And then we multiply that with the derivative of the exponent, which is cosine of x. And then we're multiplying that with x squared. And then we have the derivative of x squared, which is 2x, e to the sine of x. And then this whole thing is getting divided by x to the fourth. So let's write this a little more nicely. So we could write this as x squared. I'm debating what to put first and last. Let's maybe put e to the sine of x next, times cosine of x, minus 2x e to the sine of x. And this one we actually can simplify something, right? Because we have x to the fourth in the denominator. And so we can reduce everything by 1 power. So we can make this instead x cubed, and this will just become x, and this x will go away. And so we're left with x e to the sine of x times cosine of x minus 2e to the sine of x, all divided by x cubed. Okay, so last example I want to do, maybe let me go to a new page here. It's a little bit different than the other ones. So let me write this out. Sine of e to the x squared. So this one is not, there's no product in here, right? There's no quotient, but we'll see that it's actually a problem where we have to use the chain rule twice. So let's start by thinking about like kind of the first layer of this thing. So on the first layer, it's a composite function where the outer function is sine and the inner function is e to the x squared. So this is a composite of outer function being sine of u and the inner function being e to the x squared. And then, well, it so happens that e to the x squared is also a composite. And maybe let's not write out what it's a composite of, because I don't know, I think that will just make it seem more confusing. But basically this tells us that we're going to be using the chain rule twice. So again, if we kind of stay organized with what we're doing in each step and use these placeholder notations as wanted. Go away. See, oh no, sorry. Okay. Then we should kind of keep straight what we should be doing when. So the first step here is to use the chain rule on this part, right? On the outer and inner function being sine of u and e to the x squared. So the derivative of the outer part, well, we're going to make it into cosine and leave the input the same. So that's what always happens. And then we want to multiply by the derivative of the inside function. So if you go back, for example, to the example the second example we did, it's similar at the beginning to that, right? So in this example, we had sine of a product. And so we started by using the chain rule, and we kind of use this placeholder to say, okay, now we're taking the derivative of the inside. And in that example, the derivative of the inside required the product rule. In this example, the derivative of the inside is going to require the chain rule again. So what is the derivative of e to the x squared? Well, it's e to the x squared. So again, e to a power, the derivative will always kind of repeat the function itself. And then we want to multiply by the derivative of the exponent. So the derivative of the exponent is 2x. And so we're left with cosine of e to the x squared times e to the x squared times 2x. So maybe let's rewrite this as 2x e to the x squared times cosine of e to the x squared. All right, so that is it for today. I would really recommend, I recommend this every time, but I especially recommend that you try the worksheet today, because I really think the more you can practice these examples and then read through the solutions that I wrote up, I think that will really help. I just find that this topic of trying to figure out like what rule you have to use when is the one that most students struggle with. It's one of the topics I think students struggle with the most within this class. So I really recommend, giving yourself time to try those examples and see how they go. Also on the online homework, there are a few questions that basically ask you to kind of do this type of thing. So they ask you you don't have to actually take the derivative, but there's a function and you're asked to kind of break it down. So I just want to kind of give you a heads up. If you get to those questions, they'll seem a little weird or different. But just think back to what we did here of like, what's kind of the first thing that the function is, and then what's the second thing it is. All right, I will see you next time.